So yesterday we talked about all those special angle pairs. Today we're going to work on proving those. So before we prove those, we need to understand what tools we have in our toolbox at our disposal. After today, we can add more tools, but these 4 items, well, kind of 4, are things that we can use. So we can use the linear pair conjecture, meaning if 2 angles form a line, we know they have to equal 180 degrees. We can use a vertical angle conjecture. Remember, we called that the VAC, saying that vertical angles are congruent. We are taking the corresponding angles as a postulate. Remember how we talked about a postulate is something we accept as being the truth. So if we see corresponding angles such as 1 and 2, we can go ahead and say that angle 1 is congruent to angle 2 because of the corresponding angles postulate. And then finally, we have all these properties of equalities, which are more algebra based, so like the addition, subtraction, multiplication, division, distributive property, substitution, those sorts of things. Those are all our properties of equality. Okay, so those are the items we can use in order to prove each of the sets of angle pairs. All right, so let's look at the first one. So I want to prove that alternate interior angles are congruent. So it says if 2 parallel lines are cut by a transversal, then the alternate interior angles are congruent. So I went ahead and gave you the given statement and the proof statement. So here's our parallel lines, M and K. We have a transversal T. I want to prove that angles 1 and 2 are congruent. Okay, and I also labeled angle 3 for a very specific reason. All right, so we talked about the very first step in any proof is writing our given. Okay, so I want to write M is parallel to K with transversal T. And my reason is given. Okay, and that's just right here in my given statement. Okay, that's always our first thing. Now, think back to those tools. Think back to those tools that we have. They're at the top of your paper. We have linear pairs, we have vertical angles, we had corresponding angles, and we had all those properties of equality. So let's see about what do we have here. And a good hint is use the angles that are numbered. And especially in the beginning, that's a pretty good hint of what to start with. So one thing that I notice is that angle 1 and 3 are vertical angles. So I know that angle 1 is going to be congruent to angle 3 because of the vertical angle conjecture. Now, anytime I write a statement like angle 1 is congruent to angle 3, what I want to stop and do is mark my figure that way as well. So I want to mark angles 1 and 3 as being congruent. All right, so thinking back to that list again, I don't have any linear pairs that are numbered. I have lots of linear pairs, but none that are numbered. What about angles 2 and 3? Angles 2 and 3, remember, those are our corresponding angles. So I know that angle 2 has to be congruent to angle 3. That's the corresponding angles. So there's corresponding, here's my symbol for angles, conjecture. Or no, I'm sorry, we called it a postulate. Okay, so angles 2 and 3 are congruent. Now keep in mind, we're trying to prove that angle 1 and 2 are congruent, right? So if you look at the figure alone, if we just focus on this figure, it looks like we're already done. But my very last statement over here should say angle 1 is congruent to angle 2. So because my picture over here on the right shows that it's basically there, we just have really one more step. So we can say that angle 1 and angle 2 are congruent. And I want you to understand why that is. Notice up top, these first 2 statements, both of those angles are equal to angle 3, right? Both of those angles are congruent to angle 3. So really what we have here is a substitution. So instead of writing angle 3, I can write angle 2. So this is a substitution. And that's everything. So this last statement here, let me get another color. This last statement here should always be what our proof statement says. Okay, so make sure you have that written down. The next one we're going to look at are alternate exteriors. Now this one is very, very similar. Very similar. So what I want you to do is take a minute. In a second I'll have Ms. Mooney pause the video. But take a minute. I want you to work with one partner. Okay, it's very similar to your last one. I want you to see if you can come up with how to prove that, again, angles 1 and 2. I changed how the angles are labeled over here. So how 1 and 2 are going to be congruent. So go ahead and pause the video, and then when you're ready, hit play again. Okay, hopefully everyone had enough time. So I'm going to go ahead and start my proof the way I do all proofs with my given. So M is parallel to K with transversal T. That is given. All right, then I notice I have vertical angles over here. So I know that angle 1 has to be congruent to angle 3 because of the vertical angle conjecture. I also notice 2 and 3 have to be congruent because of corresponding angles. Okay, and again, picture-wise, it looks like I have it done, so I really just need to do a substitution. And I have that same situation again where, oops, sorry, I just drew right over my 3 there. I have that same situation where both angles are congruent to angle 3, so they have to be congruent to each other. So therefore, angle 1 is congruent to angle 2 because of substitution. Now, something I didn't mention on that last proof, you could also use the transitive property here. Just because it's, if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then angle 1 has to be congruent to angle 3. Transitive property would be absolutely valid, but a lot of times in geometry you see substitution over transitive property. But either way, you would be correct. Okay, for our last proof, we're trying to prove this time not that angles are congruent, but rather they're supplementary. Okay, so again, I changed how the angles are labeled over here. Okay, but we're going to start the same way again. Okay, so we know that M is parallel to K with transversal T. Okay, there's my given. Okay, what I'm trying to prove is that I can add 1 and 2 together to get 180 degrees. So think back to your list there. Think back to those 4 items on our list. We had linear pairs, vertical angles, corresponding angles, and all those properties of equality. So first of all, I see corresponding angles. So let's use those because we've been using those a lot. Angle 2 is congruent to angle 3, and that's my corresponding angles postulate. Okay, I'm going to go ahead and mark those. Okay, now another property I see, something we haven't used yet, is angles 1 and angle 3 are a linear pair. Remember, LP stands for linear pair, and that's just by definition of linear pair. Okay, now we know that because they're a linear pair, then that angle 1 plus angle 3 has to equal 180 degrees. Okay, has to equal 180 degrees, and that is because of the linear pair conjecture. That says if you have 2 angles that are linear pair, then they add up to 180 degrees, or that they're supplementary. Okay, now look back at our proof statement. Look at our proof statement. Our proof statement needs to be angle 1 plus angle 2 equals 180. Well, we're really close, right? We're really close because I have angles 1 and 3 So if I can get that 3 to be a 2 somehow, I would be done. But look up here. We actually have a statement that says angle 2 is congruent to angle 3. So really, I can just do a substitution. Instead of writing angle 3 down here, I could just write angle 2. So I can say angle 1 plus angle 2 equals 180 degrees. And what I did there was a substitution. Okay, so on your test, this, can't remember where it is right now, it's on a Tuesday. On your test, you are going to be expected to do one of these 3 proofs. Okay, you're going to be expected to do one of those 3 proofs. Remember what you're allowed to assume, what you're allowed to use. You have your linear pairs, your vertical angles, all those properties of equality and corresponding angles. Okay, I'm going to ask you to write out the given statement and the proof statement. So what are you trying to prove? So I'll give you a statement like this up here. It says if 2 parallel lines are cut by a transversal. Remember how we talked about the if part is the given. So if 2 parallel lines, well, my lines are M and K, are cut by a transversal. It says with transversal T. That's my given. The then part is what we're trying to prove. So consecutive interior angles are supplementary. And I will give you the figure and I'll label the angles accordingly. Okay, but you're going to have to come up with what you're trying to prove. Either the angles are congruent or angles are supplementary. Okay, so everyone has been forewarned that there will be one proof on the test. It'll be one of these 3 on this paper. Okay, so next what you're going to do, I have some extra practice for you. Just all the different angle relationships. And then from there we'll review for the chapter and then your test.